Trigonometric identities. When an equality is true for all values of the unknown quantity or quantities, the equality is called an identity. By means of proving identities, it is possible to prove other identities. The fundamental identities. The 5 fundamental identities. First, sine squared theta plus cosine squared theta is equal to 1, and it is derived from the Pythagorean relation. Second, tangent theta is equal to sine theta over cosine theta, where cosine theta is not equal to 0. Third, cotangent theta is equal to cosine theta over sine theta, where sine theta is not equal to 0. Fourth, secant theta is equal to 1 over cosine theta, where cosine theta is not equal to 0. And last, cosecant theta is equal to 1 over sine theta, where sine theta is not equal to 0. And using these 5 fundamental identities, let's try to study the proof of the other identities. Let's try an illustrative example. Prove or establish the identity of tangent theta is equal to 1 over cotangent theta. So solution, tangent theta is equal to 1 over cotangent theta, then tangent theta is equal to 1 all over cosine theta over sine theta. Instead of using cotangent theta, we use this, since this is equal also to cotangent theta. Next, we have tangent theta is equal to, get the reciprocal of the denominator and multiply it to the numerator, which is 1. We have sine theta over cosine theta, and simplify, we have tangent theta is equal to tangent theta. Okay, therefore tangent theta is equal to 1 over cotangent theta. Another example, establish the identity of cosine theta is equal to 1 over secant theta. So solution, cosine theta is equal to 1 over secant theta is the given. Then we have cosine theta is equal to 1 over secant theta instead of using secant theta, we used 1 over cosine theta. Then cosine theta is equal to, get the reciprocal of the denominator. We have cosine theta. The reciprocal of 1 over cosine theta is cosine theta, and multiply it by 1. Therefore, we have cosine theta. Next, establish the identity of tangent squared theta plus 1 is equal to secant squared theta. So tangent theta is equal to sine theta over cosine theta. Therefore, we have sine theta over cosine theta. Since we have tangent squared, we need to put a squared plus 1 secant squared theta. Simplify, we have sine squared theta over cosine squared theta plus 1 secant squared theta. And then get the least common denominator. So we have sine squared theta over cosine squared theta plus, since our denominator is cosine squared theta, we use cosine squared theta over cosine squared theta, which gives you, of course, a 1. Then is equal to secant squared theta, and apply the addition property, add the numerator, then copy the denominator. So we have sine squared plus cosine squared theta over cosine squared theta is equal to secant squared theta. And then sine squared theta plus cosine squared theta is equal to 1. Therefore, we have 1 over cosine squared theta secant squared theta. And secant theta is equal to 1 over cosine theta. Therefore, we can prove now, or we can say that this is true because we have secant squared theta is equal to secant squared theta. Okay. That's it. So the identity of sine squared theta plus cosine squared theta equal 1 is also equivalent to sine squared theta is equal to 1 minus cosine squared theta, and cosine squared theta is equal to 1 minus sine squared theta. Next, the identity of tangent squared theta plus 1 is equal to secant squared theta is also equivalent to tangent squared theta is equal to secant squared theta minus 1, and 1 is equal to secant squared theta minus tangent squared theta. the identity of cotangent squared theta plus 1 is equal to cosecant squared theta is also equivalent to cotangent squared theta is equal to cosecant squared theta minus 1, and 1 is equal to cosecant squared theta minus cotangent squared theta. And in the fundamental identities, it is classified into 4. We have the quotient or ratio identities, the reciprocal identities, the Pythagorean identities, and the even-odd identities. In quotient identities or quotient or ratio identities, we have tangent theta is equal to sine theta over cosine theta, and cotangent theta is equal to cosine theta over sine theta. In the reciprocal identities, we have sine theta is equal to 1 over cosecant theta, or sine theta cosecant theta is equal to 1, and cosine theta is equal to 1 over secant theta, or cosine theta secant theta is equal to 1, and last we have tangent theta is equal to 1 over cotangent theta, or tangent theta cotangent theta is equal to 1. The Pythagorean identities, we have sine squared theta plus cosine squared theta is equal to 1. 1 plus cotangent squared theta is equal to cosecant squared theta, and tangent squared theta plus 1 is equal to secant squared theta. In even-odd identities, we have sine negative theta is equal to negative sine theta, cosecant negative theta is equal to negative cosecant theta, cosine negative theta is equal to cosine theta, secant negative theta is equal to secant theta, tangent negative theta is equal to negative tangent theta, and cotangent negative theta is equal to negative cotangent theta. Okay, that's it. That are the different types of fundamental identities.